All right, on our next video series, we're going to focus on the limit definition of the derivative. So I just kind of want to review here for a moment. If we are given 2 points, we can easily find the derivative. And again, the derivative is just a fancy word for slope. So we can easily go y2 minus y1 over x2 minus x1, and bam, we've got our slope. Now that's great for linear functions. That's the slope of a line. Most functions that we deal with aren't linear. So here's just a simple parabola. And let's say I wanted to find the slope at this point here. Well, like we just said, the slope definition is, y2 minus y1 over x2 minus x1. I need 2 points to make that happen. So our goal is to create the second point and eventually turn it into a tangent line, which we've seen in a previous video. That's a pretty bad tangent line, but you have the idea. So let me show you a quick demonstration. So what I have here is a picture of a parabola and the point. So I drew a tangent line at that point. So in order for me to find the slope at that point right there, I need to create a second point someplace on the curve, and hopefully you see that red dot there. And what we're going to create is that secant line. And our goal is to take the secant line and move it so the distance between the gray point and the red point becomes minimalized, because almost zero. So my goal is to make the distance between them so tiny, I want to approach zero, that in fact, that secant line lands right on top of that tangent line. Okay, so again, I'm going to make an arbitrary point someplace else, and I want to make the distance between my gray point and red point become so tiny that it eventually is approaching zero, a zero distance between them. So then I can easily calculate the slope at that point. But in theory, I needed 2 points. And that's what we're going to practice today. So I want you to highlight this in your notebook. This is the limit definition of the derivative. Okay, so put a box around it, highlight it. This is the limit definition of the derivative. So dy dx, of course, is our derivative, our slope. And basically, we're taking the 2 points, the x1, y1, x2, y2, and we're saying the limit between them, we want to approach zero. We want to bring those 2 points so close that there's like a distance of zero between them. And we're going to attack this algebraically today. So we're going to work through a couple examples and work this out algebraically. It's going to take up a lot of space, and we need to keep things really neat and precise. So when it says find the derivative using the definition of the derivative, we're going to start that limit as h approaches 0, f of x plus h minus f of x all over h. Okay? So it's really important that limit stays in front until we actually substitute it in. So we're going to take that limit as h approaches 0. And the first thing we're going to find is f of x plus h. So I'm going to go to this f of x function, and I'm going to replace all my x's with x plus h. And I'm just going to jot it down at the top to keep it straight. Eventually, you'll start to do it in your head. So I want to find f of x plus h. So I'm going to go through and replace every x with x plus h. So 7 minus 6 times x plus h. Notice when I substitute, I am using parentheses. So that's what's going to go in place of this piece. 7 minus 6 times x plus h. And in fact, I'm going to put brackets around that first section and then minus. Now I'm just going to rewrite whatever f of x is. And again, I'm going to put brackets around that. 7 minus 6x. Now you might be asking, why do I have all these brackets, etc.? Well, every time I subtract, I have to distribute parentheses or distribute that minus sign through the parentheses. And most students forget that. So the brackets make a huge difference. It's just to really show placeholders. All over h. Okay, so now I just need to continue and carefully clean up my algebra. So when I say clean up my algebra, what am I talking about? Well, this minus 6 here can get distributed, and then this negative has to get distributed. So again, those brackets, parentheses are so important. So I'm going to clean this up again. And I'm going to go 7 minus 6x minus 6h minus 7 plus 6x all over h. Now, how do you know you did it correctly? Well, if things cancel, not everything, but if things start to cancel, you should have a good feeling about this. If you notice they're not canceling, you probably messed up your sign someplace. So notice I'll just box it in for you. Maybe I'll highlight it here. I have a negative 6x, and then I have a positive 6x. There's that canceling. I have a positive 7, and then I have a negative 7. Now again, not everything will cancel, but things should clean up nice. So right now I have the limit as h approaches 0. So I'm left with a negative 6h all over h. And we know an h divided by an h cancel out. So I'm left with just negative 6. So what we're saying is if you graph this function, we should have a slope of negative 6. Now, notice this is a linear function, mx plus b. There's no squareds, no cubes, etc. So the slope, in fact, should just be the number in front of x, and we just proved that it was. All right, so here's the second one to tackle. It's very similar. So let's start with that definition of the derivative, the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so I'll kind of walk you through it, kind of baby steps in here. So I first need to find, I'll rewrite my limit, f of x plus h. So just go to your function and replace every x with x plus h. So there's the first one. I'm replacing that x with x plus h. Do the same thing. I've got 10 minus 8 times x plus h. So now that I found f of x plus h, I'm just going to substitute that into my function. And I'm going to use brackets to say this is what I got. 10 minus 8 times x plus h. And then I need to subtract just whatever f of x is. And again, brackets. F of x was just 10 minus 8x. And I have all of that over h. So again, we've got to be really careful here. The limit as h approaches 0. And we're going to talk about we can distribute. I can take this negative 8 and distribute, and I can take this negative and distribute. So I've got 10 minus 8x minus 8h minus 10 plus 8x all over h. And then again, I know I did it right if things are going to start to cancel. So let's see, I have a negative 8x and a positive 8x, positive 10, negative 10. So it looks like I'm left with the limit as h approaches 0. I have negative 8h over h. Those divide out, and I get negative 8. Now, could we have guessed that from the function? Well, this is linear, right? It's in the form of mx plus b. The number in front of x is my slope, so negative 8, and we did verify that. Now, again, that's only because these are linear. That is not going to happen in most of the cases that you'll deal with, and you'll see in the next example. So in example 3 here, you notice this is not in the form mx plus b. So we can't just say the slope is 5 or negative 1 or whatever. We've got to use this formal definition. So let's start with the limit as h approaches 0. Notice I'm writing the definition down every time. X plus h minus f of x all over h. Okay, so I need to go to my function and I need to find f of x plus h. So I just go to this function f of x and I replace every x I see with x plus h. Now, in the problems we've done previously, there's only been one x, but notice in this case, there's 2. So we have to be very, very careful, and it's just a lot of algebra. So 5x plus h squared minus the quantity x plus h. So again, every time I substitute, I'm substituting with parentheses. All right, now that I know what f of x plus h is, look how simple. We're just going to say it's the limit as h approaches 0. I can replace all of this with what I just found. 5 times x plus h squared minus the quantity x plus h. And I'm going to wrap it in a nice big bracket to say that's that first function. Minus the second function, which is literally what f of x is. 5x squared minus x all over h. Okay, so parentheses and brackets. Now, the only catch in this one is I got to do order of operations. So you'll notice I have a squared here. So who am I squaring? Am I squaring the 5x plus h or just the x plus h? Well, this squared is only sitting on the x plus h. So we do have to FOIL that out. Now, hopefully, your algebra skills are pretty good and you can do that in your head. If not, you're going to have to do a little algebra off to the side. And I'll work it out up here. X plus h squared really means x plus h times x plus h. And we can go through and FOIL. So I've got x squared plus 2xh plus h squared. Again, I did a little in my head. X times x times h times x. Obviously, those are the same thing. That makes two of them. And the h squared. So I have the limit as h approaches 0. So big bracket, nice and neat. Lots of steps now as they get uglier. 5, I'm going to replace that middle step with my x squared plus 2xh plus h squared. I can take this minus sign and distribute. So I'm going to say minus x minus h. And then minus this quantity, 5x squared minus x, all over h. Now I still have cleanup to do here. Why? Because I have to multiply this 5 into that function. So I have the limit as h approaches 0. All right, I've got 5x squared plus 10xh plus 5h squared minus x minus h. Now I'm going to distribute this minus 5x squared plus x all over h. Okay, now we'll look for the test. Do things start to cancel? Let's see. I have a positive 5x squared and a negative 5x squared. Positive x and, negative x and positive x. And that looks like it. But something canceled, so I'm feeling good about it. So I have the limit as h approaches 0. I'm left with 10xh plus 5h squared minus h all over h. Now, we'll go back to a very simple method. On top, we can take out the variable h. We can pull out a GCF. So again, I have the limit as h approaches 0. I'm going to pull out an h. So I'm left with 10x plus 5h minus 1. Don't forget, when you distribute this, you have to get what you started with. So this h divided by h should be a 1 all over h. Now, why did we do that? Well, I have to take this h and divide them out. Now, I'm going to take this h and take 0 and substitute it into every leftover h. So I'm going to get 10x plus 5 times 0 minus 1. That cancels, so I get 10x minus 1. Now, you'll notice that this slope didn't come out to be a whole number like our previous examples did, and that is because this is not a linear function. So the moment that our function is not linear, we're not going to get just a number for an answer. We're going to get a function for an answer. Okay, so our final slope, I just want to be clear, this is the slope because that's what we were finding. The slope of this function is 10x minus 1. All right, let's give another one a whirl here, and I'm going to encourage you to slow down and pause it and do the best you can in trying to evaluate it on your own. So again, I'll get you started with that limit definition. And I'll give you a moment, pause it, find your f of x plus h minus f of x, and then let's compare that line. So I'm going to pause it, you pause it, and compare that line. All right, so hopefully you can see above that I substituted in my f of x plus h, which I've got there, and I just rewrote it in here minus that function. If you're good there, again, pause it, and I want you to FOIL this out, put any, and distribute this, and let's clean up that next step. So compare again, I FOILed mine out. I distributed my 2, and I distributed this negative through the next function there. So now I'm going to start to look for things to cancel out. I've got my x squared and my negative x squared. I have a positive 2x and a negative 2x and a negative 9 and a positive 9. So you notice the only things that keep remaining are the terms that have h's in them. So I'll encourage you, again, to pause it, and we'll kind of compare. So here's my cleaned up version on this line here. If I plug a 0 into all the h's, I end up getting 0 over 0. So that's why I'm pulling out this h as the GCF, canceling those h's, and then I'm substituting a 0 into every h. And I end up with 2x plus 2. So again, I just want to be clear that this is my slope, my dy dx, my f prime, my slope of that function is 2x plus 2. So our last two examples get a little uglier. Number 5 here obviously deals with the square root, so we know everything's a little uglier with those roots in there. But we're going to attack it the same way. The limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so again, we're still going to find f of x plus h. So I need f of x plus h. So that's just the square root of 5 times x plus h plus 2. And I'll substitute that into my f of x plus h spot. So I have the limit as h approaches 0. All right, so remember how I said keep things nice and neat. 5 times x plus h plus 2 minus the f of x function, so I'm going to put that in a bracket, minus f of x, which is the square root of 5x plus 2, all over h. Sorry, I got a lot of extra noise today. So do you notice all these radicals? That's going to bring back our old friend, the conjugate method, to clean this up. So I'm going to multiply carefully the top and bottom by the conjugate of the radicals. So I'm going to multiply the square root of 5 times x plus h plus 2. And the conjugate would now be plus the square root of 5x plus 2. And I need to do that to both the numerator and denominator. Whew. All right. So now we're going to talk about cleaning this up. So remember, just like we did before, you don't multiply the part where there's not a radical. So this denominator here, this is a radical times something that's not. We just rewrite it. We don't actually multiply that out just like we did previously. So the denominator is just going to be the h times, I'm going to use this bracket, square root of 5 times x plus h. This plus 2 should be in the radical. Sorry about that. Plus 2 plus the square root of 5x plus 2. Now, I do have to multiply the top out, and it's not hard, remember, because they're conjugates. The middle terms cancel out, and a radical times itself is just the stuff under the radical. So this function times itself is just the stuff under the radical. So I just get 5 times x plus h plus 2. Then my conjugates, again, the whole point of being conjugates is wonderful because this times this is a positive something and this times this is a negative whatever, and the positive and the negative cancel out, so those are gone. And now I just need the last terms. So this function times itself, again, is just 5x plus 2, and a negative times a positive makes it a negative. So now I have, I'm going to bracket that in, of course, minus 5x plus 2. Now, again, those brackets are so important because I have to make sure I'm distributing negatives. So I'm just going to clean this up again. So I have the limit as h approaches 0. So if I distribute, this is going to become 5x plus 5h plus 2. Distribute this, minus 5x minus 2. Don't touch the bottom. Okay, it's just is what it is here. So h times that chunk in the bottom. And again, you know you did it right if things start to cancel out. So 5x and negative 5x, positive 2 and negative 2. So if they're not canceling, go back and look for your mistake. So on top, I'm left with 5h. Instead of rewriting it, I'm going to say there's a 5h. And there's an h here, so I'm going to divide those h's. So I am left with the limit. On top, I have 5. On the bottom, I just have the square root of 5 times x plus h plus 2 plus the square root of 5x plus 2. And I need the limit as h approaches 0. So I'm going to replace any h's with 0. It looks like, I don't know how to keep hitting. It looks like there's only one h right here. So I'm going to substitute my 0 into there. So I have the limit as h approaches 0. So I'm left with 5. If I plug a 0 in there, I get 5 times x plus 2 plus the square root of 5x plus 2. Notice these are the exact same, so I'm just going to say I have 2 of them. 2 radical 5x plus 2. So here is the slope of that function. A little ugly, but there you have it. All right, last example for you. Again, we're going to find the definition using that limit process. So the limit as h approaches 0, f of x plus h minus f of x all over h. So again, the first thing I'm going to do is replace every x with the x plus h. So I have f of x plus h equals 1 over x plus h minus 2. So this is going to turn into a nice big complex fraction. X plus h minus 2 minus 1 over x minus 2 minus just the f of x all over h. All right, so now my goal is to clean up this complex fraction. And if you remember from a couple of days ago when we talked about cleaning up these fractions, we just said we're looking for the common denominator. So to make life simple, we're basically just going to take one of each denominator. Now, currently, the denominator of my h is just h over 1. So if I look at all my denominators, I have x plus h minus 2, and I have x minus 2, and I have a 1. Those are my 3 denominators. So I basically just want to give everybody the same thing. So here we go. The limit as h approaches 0. So everybody needs the same thing. So this needs, it's currently 1 over x plus h minus 2. It's missing the x minus 2. So I'm going to multiply the top and bottom by x minus 2. Obviously, they all have a 1 in common. Minus, this function is 1 over x minus 2. It's missing this one, the x plus h minus 2. To the top and bottom. All over, I have the h over 1. This is missing both of them. This needs to be multiplied by the x minus 2 and the x plus h minus 2 to both the top and bottom. Okay, so just like when we see these fractions, our goal is to get common denominators. So now just take a quick look. You know you did it, right? If they all look the same. Is that the same denominator, that the same denominator, and that the same denominator? If your answer is yes, you know you're on the right track. All right, so now let's clean it up again. So I have the limit as h approaches 0. So when I multiply the tops out, right here I'm going to get x minus 2 all over that denominator, x plus h minus 2x minus 2, minus, multiply the top. So I'm going to bracket that in as my first fraction minus my second fraction. I have x plus h minus 2 all over that quantity. All over, on top, I'm just going to write it down. Don't really multiply anything out too much. Just write it down. All over the denominator. Now remember, here's the best part. Once you get functions with all the same denominator, they will cancel each other out once they're all the same, which is nice because now that cleans up this function greatly. So I have the limit as h approaches 0. I'm left with x minus 2. Now I have minus this amount, so I have to make sure I distribute. So minus x minus h plus 2 all over, and I'm just going to write the denominator down. H times x minus 2 times x plus h minus 2. Okay. Now again, things should clean up. X and x, negative 2, positive 2. So all that I'm left with is a negative h over this function. Now, if you try to substitute 0 into h, you're going to end up with 0 over 0, and that's because something can cancel or divide. This h can go into this h. So I'm really left, I'm going to have to arrow up over here. I have negative 1 over x minus 2 times x plus h minus 2. And now I'm going to go back and I'm going to substitute that 0 into h. So I'm left with negative 1 over, I'll have x minus 2. That becomes a 0 times x minus 2. So I can say that final answer is -1 over x minus 2 squared, because x minus 2 times x minus 2 is that function squared. And there you have it. So we'll have 5 similar practice problems for you, and please hit me up with questions.